Hello and welcome. Today, we're going to pull back the curtain on that magic box that is your computer. We're going to try and demystify what's really happening inside by following just one little piece of data on its amazing journey, from your fingertips right through the machine's brain and then back out to your screen. Okay, let's just dive right in. I mean, it really does feel like magic, doesn't it? You click a button and this whole world just appears. But it's not magic at all. It's a process, a very, very logical, step-by-step process. And to really get it, we first have to understand that every computer is kind of living in two different worlds at the exact same time. So, what are these two worlds? Well, you can think of them as the physical and the non-physical, or maybe even the body and the soul of the machine. We know them better as hardware and software. And here's the thing, a computer is totally useless unless both are working together perfectly. And the difference is actually super simple. Hardware is all the stuff you can physically touch. You know, the screen, the keyboard, the little silicon chips inside. Software, on the other hand, well, that's the set of instructions that tells all that hardware what to do. You can't touch it. It's kind of like the ghost in the machine that brings the whole thing to life. So for our data's journey to even begin, we've got to get it from our physical world into the computer's world. This very first step is called input. It's the gateway, really. It's that moment we translate what we want to do into a language the computer can actually understand. This is where the journey for our piece of data officially kicks off. Now, at this stage, what we're entering is just raw data. A really good way to think about it is like ingredients before you start cooking. We're just feeding the computer the basic, unstructured stuff. The letters you're typing, the sound of your voice, a click of the mouse. It's all just waiting for some context. And we do this using a whole bunch of different input devices. The keyboard and mouse are the obvious ones, of course, but a scanner is a fantastic example. It takes a real physical photograph and turns it into a digital file. It literally translates it from the tangible world into the intangible one. Every single one of these devices is a bridge into the computer. Okay, so our data is now inside the machine. What happens now? Well, this is where the real magic seems to happen, the processing phase. This is where the computer takes our raw data and actually starts thinking. The star of this whole show is this central processing unit. You've probably heard of it, the CPU. It is the brain of the whole operation, and it's responsible for carrying out all the instructions. Its speed is measured in gigahertz, which means it can perform billions of operations every single second. But this powerful brain isn't just one single thing. It's got a few key parts that work together just perfectly. Inside that CPU, there's some incredible teamwork going on. First up, you've got the control unit. Think of it like a traffic cop, directing the flow of all the data. Then there's the arithmetic logic unit, or ALU. That's the system's calculator, handling all the math and the logical decisions. And finally, you have the registers, which act like a tiny, super fast workbench, holding whatever piece of data the ALU is working on at that exact moment. Let's look a little closer at that calculator, the ALU. It basically has two main jobs. The first is arithmetic, simple math like addition and subtraction, which always gives you a number. The second is logic, making comparisons, like asking, hey, is 4 greater than 2? And the answer there isn't a number, it's a simple true or false, which is the binary foundation for all complex decision-making in a computer. So the CPU is processing billions of things a second, but it needs a place to hold all this data and all the instructions it's working with. Well, that place is the computer's memory. And just like our own brains, it has both a short-term and a long-term memory. Primary memory, or RAM, is the computer's short-term memory. It's incredibly fast, but it's also what we call volatile, which means when you turn the power off, everything that was in it just vanishes. Poof! And that's actually a trade-off. The technology that makes it so fast needs constant power. Secondary memory, on the other hand, like a hard drive or a flash drive, is the long-term storage. That's where you save your files permanently because it's non-volatile. It holds onto your data even when the power's off. All right, our data has been input, it's been processed, it's been stored, it's been transformed. The final step of its journey is to come back out into our world, but now as something meaningful. This is called output. And notice the change in wording here. What went in was raw data. What comes out is processed information. The computer has taken those raw ingredients, it's followed the recipe from the software, and it has created a finished meal for us. And we get this information through all kinds of output devices. A monitor shows us visuals by turning data into light. Speakers turn it into sound.
And a printer, well, a printer creates what's called a hard copy, a physical version of a digital document. All of these are bridges from the computer's world back into ours.
And here's a great little piece of trivia for you. The reason we actually call them monitors is because, way back in the day, they allowed programmers to literally monitor the results of their programs in real time without having to waste tons of paper printing everything out. It was a direct window into what the machine was doing. So, from input to processing to output, that's the whole journey. A simple, logical flow that, when you do it billions of times per second, creates everything we see and do on our computers. It's not magic, but it is pretty incredible. Which leaves us with a really fascinating question to think about. Now that we understand the process, what are the true limits of what this simple loop can actually achieve?